if x is not AI, it's incomplete. So if I multiply this side, okay, here's the thing. If I multiply this side by an indicator function of A, okay? And I have an indicator function AI of x. What this would become at? So this would be B times indicator function of AI of x, A of x, and union. But okay, you have to be careful because you're going to say, what is the meaning of multiplying a number with a set actually? Okay, so you can't just simply write it. But I can do it if I apply a new on it actually. So let me apply new on this set. Okay, so let me apply, new, because you are talking about the parts of B actually. So new of this set. So it's going to be new of fx of E equal to sum I equal to 1 to n, new of fx of EI actually. Okay, so you're going to get this. Now if I multiply this with indicator function of A, and I multiply this by indicator function of AI of x, then what can I do? So I can do this actually, so indicator function of A of x, then this is nothing but this is new of B actually. Get it? This is new of B. So I equal to 1 because x are from, so it's like when I have this x are from the A actually. So this would be new of Bi multiplied by the indicator function Ai of x. Okay. And now I'm saying that integrate both sides with respect to d mu. D mu. So integrate both sides with respect to d mu. So yeah, so I have a finite sum. I can take that integral inside. Okay. So this is a number I can pull it out. So I have an integral of the indicator function actually. So that would be mu of A multiplied by mu of B. And on this side is going to be sum I equal to 1 to n.
Mu of Bi.
Mu of AI multiplied by mu of Bi. And this is what? This is your lambda of A cross B, which is same as lambda of E. Okay. And this is the sum I equal to 1 to n lambda of E actually. So what does this show? This shows that lambda is additive. Okay? Additive. But you have to keep in view. So are we happy with this argument? It seems it's not that difficult. Okay, you can see Basit gives a very messier argument actually. Okay, I find this very clean actually. It makes all sense. Okay, so what is the next thing? The next thing is I want to extend the same thing but up to infinity so that it becomes a measure. This lambda kind of becomes a measure on this, or pre-measure basically on the sigma-algebra A cross B. But doing this the same would be very easy actually. Think about it. It's not a difficult thing, so I can do it in a second. Just think about it. So what next I can do is that, so if I take, for example, disjoint EIs from, what do you call, A cross B, and E is the union from I equal to 1 to infinity. Okay? So you have to be careful. Sigma, okay. You have to be. Okay. E is the union of I equal to EI. Okay? EI. And you have to be careful now, E is not necessarily in A cross B. Because A cross B is not a sigma algebra. But my claim is that the conclusion will still be true actually. Okay? So E is not necessarily A cross B. So what is true? True is this actually. What would be the section of this union? And I'm assuming again that E is A cross B and EI is AI cross BI. Okay? So extension is easy. So the union of I equal to 1 to infinity would be what?
Sir, you said E might not be A cross B, but you're taking again E is to be A cross B.
What do you mean by that? I'm taking
E to be A cross B.
Yes, this is true. So are we talking about here A cross B or the collection C actually? Or product sigma algebra? Okay, let's not take it. Let's only assume this. Okay, I'm allowed to do this, at least for this. This is true in general actually. I equal to 1 to infinity Sx of EI. So whether it's true for countable things. Okay. And obviously this is my Sx of E. Okay. And then I want to do the precisely same thing. Let's apply nu on both sides. So I'm going to get nu of Fx of E is going to be sum because nu is a measure. There's no trouble with it. Nu of Fx of EI. Are you getting the point? Okay. If I multiply indicator functions here of AIs of X, okay, and I integrate both sides with respect to d mu, okay, with respect to d mu. So, can I take integral inside?
Yes, sir.
The answer is no.
Infinite, sir.
It's infinite sum. But for integral, you don't have. By the way, we have proved a result actually. If you have good functions, you can do it actually. Otherwise, I can do the monotone convergence. I can say that okay, this is the integral of the limit n goes to infinity of the partial sums basically. Okay, of S nu of Sx of EI, where I goes from 1 to n. So I can do it. And then I can apply monotone convergence theorem. I can pull this out. By the way, I can replace this with BI. Okay, I can replace this with BI. And I have indicator function of AI of X d mu. Now I can do it by monotone convergence theorem. I can take limit and goes to infinity of the finite sum I equal to 1 to n of the integral I, okay, times indicator function of AI of x du. And then I can say that, okay, this would be same as that you have this sum I equal to 1 to infinity. This would be essentially mu of AI multiplied by mu of BI. So it would be lambda of EIs actually. Okay? So it's lambda of EIs. So isn't that we wanted to show? Isn't that we wanted to show? No, but still this side is not settled actually. We don't have so I need to multiply by the indicator function. But indicator function of what actually? Okay?
Indicator function again is
Okay.
This is what they are like. So let me have a quick look on. So sigma S sigma L is a measure on A naught. There is sigma finite, then there is a T extension. L of union of AIs.
sigma field sigma field algebra खाली algebra lambda mu and mu by major lambda ये गाला व्हाट्सएप को
In other words, another thing saying that L is an inordinate following one of the definition 3.1. Okay. Here's the thing. So in Caratheodry extension theorem, you have this assumption that you assume that it belongs to A cross B. So you have to kind of assume it. Okay, so it's there. So it's not that it follows from definition. So you have, some chunk of disjoint sets such that their union is there. Okay.
union finite या वो
infinite. So it's like obviously. So it's like okay. So we reach to a point from where we have no escape actually. So if I assume that E is in this set, then I can resolve the matter actually. Okay. So we are assuming that E is in A actually. So if E is in A, then obviously the E would be A cross B, and then I can say that this side would be lambda of E actually. So lambda of A cross B by the same argument that you named previously as lambda of E. Okay.
सर फिर वो सिग्मा फील्ड नहीं बन रही वो तो हम कह रहे हैं A cross B
So sigma field says, okay, here's the thing. So I have an algebra. Okay, I have an algebra, and so it contains all finite unions. Okay, but as a special case, I am adding another element into it. it's what do you call the countable union of it actually. So I'm adding to it actually. So nobody can, you know,
हाँ ठीक
what
है
do you
उसको
call?
सेट को
So I'm just extending it actually. And adding this is not going to create any trouble. Because if I have to take this union of this element with other element, then I'll treat this element as a single element actually. So I'll say that A, so would E union E1 be in A cross B? The answer is yes actually. So if I assume this is in A cross B, so that's a single element actually. So their union and hence the finite unions would be in A cross B actually. So there is no trouble if you assume this actually in A cross B. So you can insert a set. So we have inserted a set actually. Once you have done this basically, then we have satisfied all conditions, okay, of the Caratheodry extension theorem actually. So the Caratheodry extension theorem, once we have this, but there is one little thing still. There is one little thing still. To get an extension, you need to also show that lambda is sigma finite actually. There is one thing, not to rush. So in Caratheodry theorem, it's the case that okay, you have this pre-measure, but you should have also sigma finiteness. Okay, so that would be just one line of proof.
सर हम ये प्रूव कर रहे थे ना कि C जो है वो सिग्मा फील्ड है.
So we haven't showed that. Okay, we haven't lost it. So what we have shown is that okay, I have this A cross B, and it's algebra. So this is like my A naught in Caratheodry extension theorem, and I have some notion of length L, which goes from A cross B into 0 to plus infinity. Okay, and then this is what do you call a pre-measure. Okay, it's a pre-measure basically. Now once we have a pre-measure on an algebra, and in addition I show that this is sigma finite, then I can extend it to the sigma field generated by this rectangle essentially, which is the product sigma. Okay. So that notion of C was just an intermediary step actually, which kind of helped out to sort out some of the things actually. So why this should be sigma finite? Just and quick and you have to assume. So in order to do this, you have to also assume that mu and nu are sigma finite. Okay. The one and the last claim is that if mu comma nu are sigma finite, okay, then lambda is sigma finite. Okay.
सही
Quickly to see that what is meaning of mu being sigma finite.
Mu of x.
व्यू
Okay. So mu is sigma finite. This means that there is an increasing sequence. Okay. So it's like A1 contained in A2, contained in A3, and so on and so forth. There is an increasing sequence of sets from calligraphic A such that their union is equal to the whole x equal to 1 to infinity A. Okay? And the measure of each of these AIs is finite. Okay? So what we are saying is that, so it's kind of a relaxing assumption. So you may assume that your measure is finite. So it means that the mu of x is finite. But this is relaxing the assumption actually. So I'm not assuming that the measure of x is finite, but x can be written as the union of the sets
whose measure
is finite.
सही
इस लिहाज से है कि then x can have finite measure, but x can have infinite measure as well, because the measure of x would be a series actually, and it's not necessary that that series must converge actually. So that can diverge as well. Okay? And similarly, you're going to have AIs for mu and x, and similarly, you're going to have for nu, because it's sigma finite. So you're going to have, B1, B2, increasing sequence, increasing to x, in other words, such that union of I equal to 1 to infinity Bi, okay, and what? And the nu of Bi is finite. Okay, finite. So in order to show lambda finite, in order to show lambda sigma finite, what I need to do? I need to find an increasing sequence, okay, of sets which increases to calligraphic A cross calligraphic B, collection of all rectangles actually. And each of that element in the union has a finite measure. Okay? The claim is this, that this this x cross y can be written as union of I equal to 1 to infinity AI cross B. Okay?
And definitely
You have to be careful. If this sequence would not be, because what we are saying is that, so what does this essentially means is that you are saying that union, what does this means in the sense of union of I equal to 1 to infinity AI cross union of I equal to 1 to infinity Bi is equal to this actually. Okay? This is not true in general. This is not true in general. This is true only because of the increasingness actually. So if you have increasingness, then you can have the equality. Think about it. Well, that's not true in general. So how can I show this actually? Think about it. How can I show it? So if I pick and point from x comma y, from x cross y, what are you going to get? So this would be in x and this would be in y. This implies that x would be in some ai and y would be in some bj. I and j are two indices. Now either I is less than or equal to j. So without loss of generality, assume that I is less than or equal to j. Okay? Now since the sequence is increasing, the ai must be contained in aj actually.
So x is in
So x must be in aj.
AJ
And hence,
and xy is in
yes, xy is in
AJ cross BJ in the union.
x cross and ai cross bj and in the union. aj cross bj and in the union. But like this side is trivial obviously. Okay? So once you have this, then you just only need to show that lambda of these guys are finite actually. And this is of course finite because lambda of ai cross bi is equal to mu of ai cross nu of bi, and both are finite, so this must be finite, and you are done with the theorem. So you are done with all assumptions of Caratheodry extension theorem, and hence as a result you get, so I would like to formulate the last, what do you call, a meta theorem. Okay? So the meta theorem is, and we have already proved that theorem, that there exists a measure, okay, from the sigma algebra generated by the collection of all rectangles into, and that would be a unique measure, 0 to plus infinity, which extends lambda. okay, which extends lambda. I'm giving this measure a name actually, and that name is the product of mu times
New.
mu1. Okay. And you can call it tensor product because just see the definition, think about it. It's almost like a tensor product, okay? But you can't call it tensors because you're not talking about linear things actually. Okay. So what we have as a result, so using two measure spaces, we constructed a measure space and then measurable space, and then we constructed a measure on it. So that's, we are done with this. You know, so we constructed a product measure, and now you can, if you wish, you can extend it. So I can show that I have n measure spaces. So you know, and then you can have a, you know, so inductively you can go beyond it. So it should be an easy task.
Summarize करेंगे.
हाँ?
आखिरी वाली चीज summarize करेंगे.
Summarize.